Hi, I'm Felipe Hoffa, and today we are at NOAA, the National Oceanic and Atmospheric Administration. Today we're going to visit their Science on a Sphere project, where they are able to visualize all the information, everything that is happening around the world in a giant 3D sphere. We are going to use this sphere to take a look at GDELT, the Global Database of Events, Language and Tone, an initiative that collects, classifies, and scores every piece of daily news it can reach from anywhere in the world. In this video, we are going to see practical examples of how to explore GDELT data with BigQuery. We are going to meet Amanda Traud to see how she's using R to explore the ever-changing relationships between countries. We'll also meet Louisa Koch, the NOAA Education Director, to explore the amazing possibilities that emerge from combining GDELT with other datasets. But first, let's go back to NOAA to meet Kalev Leetaru, the creator of GDELT, to learn more about his project and how it works. So this is NOAA's Science on a Sphere project, where we can visualize the whole planet at once. Here, for example, we're looking at the Chilean 2014 tsunami and how it's expanding all over the world. But then, can we look at GDELT? Let's wait for a second to load, and here we have it, all the protests around the world. And Kalev, can you tell us more of what we are looking at here?
So the idea of the GDELT project really is, how do we create a dashboard, if you will, of human society? If you think about it today, an earthquake occurs anywhere on the planet. And this massive global sensor grid that's been set up, groups like the USGS can pick up the fact that this earthquake occurred anywhere on the planet. They know where it is, what its depth is, who's going to be affected, all within seconds. But what about human earthquakes? If you think about it for a moment, a protest that occurs anywhere on the planet, the ability to create a data set of that, and that's really what the GDELT project is about, is creating essentially a global catalog of human society. So imagine scooping up all the world's news media each day, web, print, broadcast, over 100 languages, and processing all that by computer, second by second. How do you interact with that, visualize that, understand that? And that, to me, is what's so exciting about the NOAA Science on a Sphere project, is this ability to take this massive data set of 250 million records and make it accessible. You think about visualization. You can't do better than to display essentially planet Earth on a physical sphere of the planet.
While visiting NOAA, Louisa Koch, the Education Director, joined us to share more about their mission and her thoughts on the GDELT dataset.
So NOAA produces a lot of information about the ocean and the atmosphere. We spend billions of dollars a year collecting ocean and atmospheric data. But it's really important for us to also connect it to what that means to people. And GDELT is an amazing database. It's so exciting to see it on the sphere. Right now, most of the data sets on the Science on a Sphere are the physical data sets that talk about how the Earth is operating. GDELT talks about how social systems are operating and can show us a completely new perspective on the planet that we call home.
So GDELT is amazing, it's monitoring the world, but what I want to learn today is how you're getting all this information into GDELT.
Yeah. So that's one of the tricks is, trying to monitor the entire world's media. And of course, this is a complex process. So it's taking this textual news article, this big, massive mess, and translating that to a codified record that's recording what's happening, where it's happening, who's involved, the details of it. And then all that flows through to the end, where it then makes it available as these CSV files and sitting inside a BigQuery. And then eventually at the end of each day, when it processes it, it generates a CSV file, makes it available on the website, but then it also sends it to BigQuery using the BigQuery uploader tool. And a minute or so later, it's up in BigQuery and it's been added to that 250 million record. So now you can pull up BigQuery on your computer and suddenly access the latest material.
GDELT already indexes more than 250 million rows from the last 35 years of worldwide events, and is growing by more than 100,000 rows a day. I sat down with Kalev for an interactive session of exploring GDELT using BigQuery. Take a look at what we did.
What we're going to do here is do a simple experiment to show, how do you really work with data. So why don't we start off with Ukraine? Ukraine's been in the news, obviously, a lot. Why don't we see, let's pull, for example, let's just count how many total events that we're getting from Ukraine right now. And specifically, let's look at conflict events, since a lot of the Ukraine event. So what we want to do, in this case, we just care about the number of events. We don't care about the detail. We just want to know how many events are occurring in Ukraine by month, for example.
By month. for the last year, for the last 10 years?
Let's do for the last 30 years. Let's go back to 1979.
Let's do that.
So we'll start off with a select count, as usual. And what we want to do is we want to say, first off, we want to limit it just to Ukraine, obviously. And so we're going to say action. So what we're going to do is we're going to say where action, so for each event, it records a whole bunch of different details. One of them is where the event took place, so the physical location where the event took place. So we're going to say where the country code of the action, where it actually took place, is UP. And don't ask me why UP is the country code for Ukraine. And so if we just do this and we say, well, where the events by Ukraine, but we want to break that down by month. So we're going to say, we're going to come back here and we're going to add in month, year. And so basically we're asking it, break this down by month, count up the number of events, and again, group by month, year, and let's order by month, year. And so if we run this, what we should get back here is literally by month, how many events it counted in Ukraine. And actually, I just realized this will give us everything, but this is a good example. This will give us everything, not just conflict events.
Maybe we need to,
Okay,
there it is. So what do we have here? Can we look at the
So what
results?
we're seeing here is by month is how many events it actually recorded. So you're seeing in January 1979 it recorded 23 events, in February it recorded 11, and we scroll by. And let me hop all the way to the end. So you notice these are sitting in the 50 to 80.
Okay, we have 430 different months.
Exactly. If we come to here, we start seeing like 100,000.
Wow.
And if I download this, let me download this as a CSV file and show you what this actually looks like. And let me go ahead and graph this. So this is, I love visual, so it makes it easier to see. So let's go ahead and graph this, and we can see, wow, there's not a whole lot in Ukraine, and then right as, you can see, a certain number, maybe 100 or so a month or so. And then, of course, the fall of the Soviet Union starts increasing. We start seeing some of the other. Then, of course, we really see things skyrocketing, in recent times. But, and you could say, well, that kind of makes sense. I mean, there's a lot of stuff that's been happening the last year. But the problem that's facing us is that at the same time, the total volume of all news media worldwide is increasing exponentially. And so if I use, so what you really want to do here is you actually want to normalize this. I don't want to see a raw number. What I want to see is I want to see that over the entire size of GDELT on that day.
So in order to normalize the number of events, we need to know two numbers. First, the total number of worldwide events in GDELT for each month, which we compute with a simple count, and then the number of events related to the Ukraine. We can get those adding an if condition to our count clause. Finally, we need to get rid of this old where clause. Otherwise, our first count would be incorrect, since only rows related to the Ukraine would be taken into account. We could now get the ratio between both columns in BigQuery. But instead, let's export them as a spreadsheet and produce the monthly ratios and visualizations there.
And so now let's go ahead and just, so we mapped Ukraine before, as we remember. If we look here, we see Ukraine. Let's take a look at the total. So this is all events found by GDELT. And we can see, obviously just, right around sort of the birth of Google News in particular, which really drove a lot of web-based news, we sort of see this massive spiral forward. And so that's so the problem is that, so actually looking at this does suggest indeed that there was a big surge in Ukraine. But the problem is that, this peak is really going to be heavily impacted by the fact that there's a lot more in GDELT than there was a long time ago. So what we want to do is, instead of plotting the raw number, we want to plot it as a percentage. So we basically want to come in here and we simply want to, do a simple dividing. Number of Ukraine events, divided by total number of events, make it into a percentage point. Now, if we graph this, it probably will look somewhat similar, but actually we see a lot more here. So now we start seeing some interesting things, and we can see again sort of all events. So we can see again sort of this rise in, in sort of interest in Ukraine. But again, one of the challenges here is we're looking at everything for Ukraine, and probably what we want is we want to go more narrow, something like protests. Because again, looking at everything to do with Ukraine is probably less interesting. So what we want to do is we want to come in here and we want to say, we want to limit it to protests. So if we want to say protests, we want to say there's something here called the event root code. So remember that there's 300 different categories of events in here. And so all the protest ones begin with 14. So if we go back, remember here, and we look at 14, we can see there's all different types of it: hunger strikes, policy, a protest for leadership change, a protest for a rally, a protest for policy change. In our case, we just want to see all of them. So if we say where the root code equals 14, that captures anything that's a protest. So now if we repeat this, we should get something much more interesting. This is going through and finding everything that has to do with the protests across all of GDELT, coming back, and then for each month, recording how many total protests were recorded in GDELT for that month, and then how many were recorded in Ukraine in that month.
So in January 1979?
It's saying that it found 400 protests around the world, and again, in 1979, there was less electronic media, but it didn't find any in Ukraine. And obviously with the Soviet occupation, a lot less. So let's download that as a CSV file. And let's once again bring this into Excel. So this is total protests. This is Ukraine protests. And then once again, percentage, Ukraine. So what this is then is, so let's say we want to divide like this. So what we've calculated, what we're going to do here, so this column essentially will be what percentage of all protest events marched in that month were from Ukraine. And if we then examine this, we plot this out, now we see something that makes a lot more sense. We see, let me delete this, give us a little bit more room here. You can see during the Soviet occupation, very few protests. Obviously, the Soviets were very restrictive on that. And then, of course, the protests, the great sort of European revolutions that began the fall of the Soviet Union. Boom! Now all of a sudden, you see a lot of protest activity. You see spikes, Crimea. You see the Orange Revolution. And then you see where we are today. But you see what's interesting is that protests have really been decreasing in Ukraine as we've been moving towards present. And a lot of that obviously is the fact that what's occurring in Ukraine right now has really shifted from protest activity to full-scale military conflict. And this raises some interesting questions. So, for example, let's go back to this query. And instead of protests, let's look at that. If we say, well, why are protests going down? Isn't Ukraine becoming more unstable? Well, instead of protests, let's go back and look at conflict. So, fighting, for example. Let's change from 14 to 19. And so now let's run this. So now what we're saying is, find me all the sort of the active conflict activities, the actual fighting that's occurring across the world. And for each month, count up how many total, how we see, and then again, how many were in Ukraine.
We continue to explore the basics of GDELT and how to look into the timeline of each country. During this trip, I also met Amanda Traud, a data scientist who's been exploring GDELT at her job. She works at L3 Data Tactics, a specialized provider of big data analytics and cloud solution services. They have been using R to explore GDELT data and the relationships among countries and how they change over time. For this project, she uses Shiny, a web application framework that turns R code into interactive web apps. Let's learn more from her.
So Shiny is actually a package in R that allows you to create browser-based applications. And both of these apps are browser-based, and anyone can use them on our Shiny server.
That's awesome. So you have a Shiny server running our Shiny apps.
Right.
Can you show me more about these apps? What have you done?
Absolutely.
With GDELT's data?
So my favorite app is the GDELT Country Network Dashboard. You can put in a date range. So say I wanted to know what the connections between countries look like in the last week. So I select October 15th and October 22nd. So again, I put in my BigQuery ID. And then I query.
Okay, so we have a beautiful network here charted. Can you show me behind the scenes?
Absolutely. So
what is powering this app?
So two things, HTML and R. First, I'll show you the R code. So R has this amazing library called Shiny that you can use to create these browser-based apps. So behind the scenes, when I get my data back from BigQuery, my R function, Shiny server, is taking the table and creating an edge list. And in a network, an edge is the line that connects the two dots. So this takes the table that I get of all the events, pulls out actor 1 and actor 2, decides in the table which ones are countries, and takes that subset, and then says that the weight on that edge, how connected they are, is based on the tone of the event.
I see. And it's all open sourced.
It is. It's all on GitHub, so you can go and you can download the code if you want.
Oh, that's
It's
awesome.
on the Data Tactics GitHub.
That's beautiful. And you have another app available too.
I do.
Uh-huh.
The second app will give us a table of all of the information that we could possibly want with GDELT. All right, so for the app, we need to put in, I've already put in a date range that is October 1st through the 22nd, and put in my project ID and client ID, just like the first one, and selected an actor. Now, I can select any of the possible actors in the GDELT database. I've selected China.
So GDELT has a lot of factors encoded. Can we take a look of
Absolutely.
Yeah.
It has
countries? It has
so
groups.
many.
So we're going to look at protests in China between October 1st and October 22nd.
Absolutely.
And this app is querying BigQuery.
Through JavaScript, exactly like the other one.
Okay.
I hit query, and it goes to GDELT on the BigQuery database.
Yeah.
And brings me back a table. And I have a list of the different columns that are available in the data.
Yeah, this is awesome. And this is data you later pick up with R and you're able to net.
Absolutely. So this is the type of data that I then take into the other app. In the other app, I use Actor 1, Actor 2, and Average Tone.
To learn more about these apps, visit the GDELT blog and explore the open source code at the L3's GitHub page.
Yeah, so how did you discover BigQuery and how did it change GDELT's
Yeah,
project?
BigQuery has been incredibly amazing to this project. So really for the first sort of 3/4 of GDELT's life, I could not access GDELT. I have 250 million records sitting in my hands, but I couldn't look at it. I couldn't ask the most basic of questions. A simple query of, give me a list of all the events involving 2 actors. That could take a day to compute in a traditional, database. So oftentimes, people would say, wow, can you give me an extract of all the events in Syria that involve a certain actor? I say, sure, but it's going to take about a day and a half for that to extract. BigQuery really opened, it was essentially taking the lens cap off of this incredible data set. BigQuery is really changing that bar now where, the vast majority of those ideas, like, could we, literally take a period of time right now and check all of world history and see what periods in world history are most similar? 2.5 million correlations, 2.5 minutes, 1 line of SQL.
Yeah, and what is next? Where is BigQuery GDELT, the data world going?
So that's the most exciting part. Is you think about GDELT today, it's out there, it's processing all the world's news media, it's creating this incredible data set. GDELT also is expanding to things like academic literature, processing all the world's academic literature on social cultural issues. And from that, we have the citation graph of who's most cited in areas. Now imagine taking GDELT, what's happening in the news today, combine that with the citation data of who all the world's experts are in an area, then combining that with Google Freebase, which gives all this structural information. So GDELT knows, for example, that there's that Barack Obama is the president of the United States. But Freebase will then tell us, well, he also attended Harvard. And then it can tell us, well, this other person over here, they also attended Harvard. So we start getting those structural links that allow us to combine with that, and then being able to correlate against other data sets that are in BigQuery. Things like the Wikipedia page views. Being able to say, well, when all of a sudden this particular person's in the news and everyone's now looking that person up on Wikipedia, what are the other topics they're looking at the same time period? How is that person or that political party or other thing, how are they being contextualized and understood? It's just magic. You just put the data out there, and it's sort of like the electricity. You think about, you walk into a room and you flip the light switch. You think about how simple that is, yet how incredible that infrastructure is that makes that possible, but you don't think about that. You flip your light switch and you don't worry anymore about how expensive is that query. You just ask the question and it's possible. Whatever you can imagine, it's possible.
And that's it for today. Thank you for joining me in this exploration journey into understanding the world. It was a pleasure to meet Louisa Koch and Amanda Traud to explore how industry, academia, government, and end users can benefit from this extraordinary dataset. And of course, Kalev Leetaru, the mind behind GDELT. To follow the latest developments and interesting use cases, visit their website at gdeltproject.org. There's a lot more to discover. Now it's your turn to dive into the data, write your own queries, and share your results. If you enjoyed this video, share it with your friends. For the Google Cloud Platform, I'm Felipe Hoffa. I'll soon be back with more stories from the big data world. Stay curious.